Welcome to the deep dive. Today, we're jumping into something pretty foundational for building apps that can actually handle success: horizontal scaling, specifically in Spring Boot. You send over the sources, articles, research notes, the works, and yeah, our job is to pull out the really key stuff for you, give you that shortcut to knowing what's what. Have you ever, stopped to think how services like online stores or ticket sites just dot work, even when thousands, maybe millions of people hit them all at once, like for a big sale or something? Or maybe you're building your own thing and you're wondering, how do I make sure this doesn't just fall over when people actually start using it? Well, today we're tackling exactly that. We're diving into horizontal scaling. Okay, so let's unpack this. What is horizontal scaling really? At its core, it's about handling more users or more work by adding more servers. Not making one server super powerful, but adding more of them, scaling out, they call it. Think of like a busy coffee shop. Instead of just getting one barista to work faster and faster, that'd be vertical scaling. You just hire more baristas or even open another shop location. That's horizontal scaling.
Right. In Spring Boot terms, it means you run your application, the same exact code, on multiple servers. Each one grabs a slice of the user requests, keeps things fast, keeps things reliable, even when demand goes way up. And it's definitely different from vertical scaling, yeah.
Yeah.
Where you just throw more RAM or a faster CPU at one single server.
Exactly. That's scaling up. Horizontal is scaling out.
And there's this key piece, the load balancer, right?
Yeah.
Acts like a tech traffic director.
Precisely. It sits in front of all those servers running your Spring Boot app and just intelligently spreads the incoming requests around. Make sure no single server gets swamped.
Okay, makes sense. So why is this such a big deal, especially if you're maybe just getting started with building bigger apps?
Well, what's really interesting, I think, is how it changes the game. It's not just about handling load. It often forces you, kind of naturally, to build better applications from the start. For instance, you pretty much have to think about making your application stateless much earlier on.
Stateless, meaning the application server itself doesn't hold on to user-specific data between requests, like who's logged in. That needs to be stored somewhere else, somewhere all the servers can see it.
Ah, okay. So it encourages good habits.
Exactly, which is great for stability anyway, scale or no scale. So the benefits are pretty clear. Obviously, it keeps your app feeling fast, responsive, even when you get those huge traffic spikes.
Like during a flash sale or a live event.
Right. And it boosts reliability massively. If one server has a problem, the others just pick up the slack. The whole thing doesn't crash.
Reduces that single point of failure.
Completely. And then there's cost, especially in the cloud. It's often way more cost-effective to spin up more small, cheap servers when you need them and spin them down when you don't, rather than paying for one giant, powerful server all the time.
Pay-as-you-go scaling, sort of.
Basically, yes. And it just makes your whole setup flexible. Your app can grow without needing, massive rewrites or re-architecting down the line.
Okay, speed, reliability, cost, flexibility. Those are pretty compelling reasons. But are there other reasons, maybe less obvious ones, why people go this route with Spring Boot? And how does Spring Boot actually facilitate this? Like, what's happening under the hood?
Well, beyond those core benefits, it's really about enabling that growth trajectory. If your app starts taking off, say your website suddenly gets featured somewhere and traffic jumps 10x.
Yeah, the dream scenario, right.
Right. Horizontal scaling means you can just add more instances, more servers to handle it without breaking a sweat. It also gives you much better fault tolerance. Like we said, one server fails, no big deal, usually. The load balancer redirects traffic.
Okay.
This is huge in cloud environments like AWS or Google Cloud. They're built for this. You can set things up to automatically add or remove servers based on the current load. That saves money and keeps performance steady.
So it manages itself to a degree.
To a large degree, yes.
Yeah.
And ultimately, users just get a better experience. Fast load times, no weird errors during peak hours. It keeps people happy.
Makes sense. So how does Spring Boot help make this happen? Is it built in or?
It's more that Spring Boot is designed in a way that works really well with this approach, and it integrates nicely with the other tools you need. So first, you just run multiple copies instances of your Spring Boot application. Identical code, each running on its own server or container.
Like multiple checkout lanes with the same cache register system.
Good analogy.
Yeah.
Second, you absolutely need that load balancer sitting in front, distributing the requests. Could be hardware, could be a cloud service like AWS ELB, could even be software like Nginx or Spring Cloud Gateway.
Got it. Distributes the customers.
Exactly. Third, Spring Boot is fantastic for microservices.
Hmm.
You can break your big application down into smaller, independent services, user accounts, product catalog, payments, whatever.
So you can scale just one part if needed.
Precisely. If your payment service is getting hammered during a sale, you just scale that service by adding more instances of it without touching the user account service, for example.
Hmm.
Much more efficient.
Like adding more staff only to the busiest food stall at a festival.
Perfect. Fourth, handling data correctly is crucial. Since any server might handle a user's request, you can't store things like login sessions in that server's memory.
Right, the stateless thing again.
Yes. So you use external tools. A distributed cache like Redis is very common. All your Spring Boot instances connect to this central Redis store to save and retrieve session data or other frequently needed stuff. Fast access for everyone.
Like a shared recipe book all the chefs can see instantly.
Yeah, something like that. And your main database needs to be set up so all instances can connect to it reliably and consistently too.
And finally,
Finally, deployment. Spring Boot apps package up nicely, usually as runnable JAR files. These are super easy to deploy on cloud platforms, AWS, Azure, Google Cloud, which have built-in features for managing multiple instances and auto-scaling them based on traffic.
so the cloud platforms do a lot of the heavy lifting for the scaling part itself.
They really do. They can automatically add or remove your Spring Boot app instances based on rules you set, like CPU usage hitting a certain threshold.
Okay, that paints a really clear picture. We get the why and the how. But let's talk pain points. What specific problems does horizontal scaling solve for a developer, especially someone maybe starting out or facing growing pains?
Oh, it tackles some very common headaches. Number one, slow performance during traffic spikes. Your app grinds to a halt during a product launch. Horizontal scaling fixes that by sharing the load. 3 servers handle the sale instead of one struggling.
Right, avoids the spinning wheel of death.
Exactly. Another one, app crashes under heavy load. A viral marketing campaign suddenly swamps your single server, boom, it might fall over. With horizontal scaling and a load balancer, the requests get spread out, much less likely to crash. Your social media app stays up.
Kicks the lights on.
Then there's the cost of powerful servers. Scaling up buying a bigger, beefier server can get really expensive fast. Scaling out with multiple smaller commodity servers, especially in the cloud, is often much more economical.
Pay for what you use, again.
Yep. And it solves the problem of limited growth potential. A single server just has a limit. Horizontal scaling means you can basically just keep adding servers as your user base grows. Your blog gets popular, add another instance. Simple.
Removes that ceiling.
It does. And all of this leads to a better user experience.
Yeah.
Slow, unreliable apps drive users away. Distributing traffic means fast responses, even during peak times. Think of a ticketing app during a huge concert on sale. Horizontal scaling is what makes that possible without melting down.
Okay, it definitely solves some major issues. So how does someone actually do this in Spring Boot? You mentioned statelessness and caches. Is it super complicated for a beginner?
It might seem daunting, but Spring Boot and the ecosystem around it make it pretty manageable, actually. The absolute key, number one thing, is designing for statelessness from the start.
Okay, hammer that point home. No user data stored on the server instance itself.
Correct. Use something external, like Redis, or maybe a database-backed session store, for anything that needs to persist between requests for a user, like their shopping cart or login status. Think of it like all the baristas using a central digital screen for orders, not scribbling on their own private notepads.
Got it. Shared notebook. What's next?
Well, if you're going the microservices route, you'll likely bring in Spring Cloud. It has tools specifically for building distributed systems, service discovery, configuration management, things like that. Makes managing those separate pieces easier.
So Spring Cloud helps manage the complexity of many small services.
Yes. Then you set up that load balancer we talked about. Again, cloud providers make this super easy with services like AWS ELB or Azure Load Balancer. You basically just point it at your group of running Spring Boot instances.
The traffic director setup.
Right. Then implement caching seriously. Use Redis, or maybe something like Hazelcast or EHCache, to store data that's accessed often. This reduces load on your database and speeds things up for all instances, like having popular coffee orders prepped and ready.
Smart. Less waiting.
Definitely. And finally, deploy it all on a platform that supports easy scaling. Cloud platforms are the natural fit here. They let you define auto-scaling groups. I want at least 2 instances, but scale up to 10 if CPU usage goes over 70%, that kind of thing.
Like automatically renting extra food trucks for a festival when the lines get long.
Exactly. So for a beginner, while there are new concepts, the tools are there. Spring Boot itself is easy to containerize, Spring Cloud helps with distributed patterns, caches are well established, and cloud platforms handle the scaling mechanics.
So it's achievable without being a distributed systems guru right away.
Yeah, I think so. It lets you build reliable, fast apps that are ready for growth. Saves costs in the long run, too.
That sounds pretty good. But
But
are there any traps, any complexities people should watch out for when they go down this path?
oh, for sure. It's not magic. The biggest thing is just the added complexity of managing a distributed system. Instead of one log file, you might have 10. Monitoring needs to cover all instances. Debugging a problem can be trickier because a request might bounce between servers.
Yeah, finding the needle in a bigger haystack.
Kind of. And that shared data thing, managing sessions in Redis, for example, has to be done right. If your cache goes down or gets inconsistent, you can have weird user experiences.
Right. This shared notebook needs to be reliable.
Absolutely. And finally, cloud costs. Auto-scaling is great, but if your rules aren't quite right, or if you have a bug causing high CPU, you could accidentally scale up way more than you expected and get a surprise bill. So you need to monitor costs and set sensible limits.
Good points. Need to keep an eye on things. So, wrapping this up, what does this all mean for you, the listener, as you're building apps or just using them? Well, it means understanding horizontal scaling is key to building apps that don't fall over when they get popular. Apps that stay fast, stay reliable, and don't break the bank. It's how you solve those common performance and scaling headaches.
And maybe a final thought to chew on, connecting this to the bigger picture. How might really grasping these ideas of horizontal scaling, statelessness, load balancing, how might that not just help you build better software, but also change how you see the big online services you use every single day? Especially think about them during those crazy peak moments, Black Friday, a big news event, a game launch. Understanding how they likely stay up might give you a new appreciation for the engineering involved.
That's a great perspective. Food for thought, indeed. Well, thank you for sharing all those sources with us, and thanks for joining us on this deep dive into horizontal scaling with Spring Boot. Keep exploring.